Our initial prototype SFF6 chassis here is aimed at 3U VPX or compact PCI applications, but this technology could be readily applied to 6U applications. For example, this 67 watt per slot chassis for 3U could be extended to a 6U application. Of course, the chassis would be larger. It would have the same thermal performance, or the 67 watts per slot, more or less, for 6U, given a 71 degree base plate temperature, which is where we're specifying this chassis. If, on the other hand, you were able to relax that requirement to a 55 degree base plate temperature, which is another common number in rugged applications, then we'd be able to handle roughly double that power level, or 130 watts per slot, which would be right in the range of where 6U is in VPX today on the high power multiprocessing applications. And CoolWall technology is cost effective. As compared to aluminum construction, the production cost impact of CoolWall is relatively modest. Also, this technology can be optimized based on the particular application to optimize the combination of weight and thermal performance. As I said earlier, this particular chassis is optimized for performance, but it would be straightforward to optimize this for weight. With a small tooling cost, we can optimize a solution for a particular application, or the customer can base their solution on existing designs such as this one that is optimized for a particular point in the spectrum. CoolWall technology will be offered in Hypercon brand family of rugged electronic packaging. What you see before you here is a base plate conduction cooled style chassis for 3U VPX or compact PCI applications. However, CoolWall is not limited to 3U applications. For example, it could be used for 6U, nor is it limited to base plate conduction cooled applications. We will be exploring the application of CoolWall to different styles of conduction cooled chassis, such as the ones you see here before you, a liquid conduction style chassis and a forced air conduction style chassis. CoolWall technology is not just applicable to conduction cooled chassis like you see here in front of me. It is also applicable to module level, such as module thermal frames for conduction cooled modules, where the aluminum construction is typically used for conduction cooled module thermal frames. Occasionally copper thermal frames are used, but of course copper is more than 3 times the weight of aluminum. So CoolWall would be a good alternative where copper is currently being used with a significant weight reduction. Also, for conduction frames, module vendors sometimes use heat pipes, and CoolWall is also potentially an alternative to heat pipes. CoolWall can be flexibly optimized to target performance improvement and or weight reduction. And we are working to further refine the CoolWall technology and hope to provide improved performance in our next generation prototype of the SFF6, where we believe we can achieve more than a 3 times improvement versus aluminum, versus the currently achieved 2.4 times in the initial prototype. If you have an application that's size, weight, and power constrained, please contact Curtiss-Wright, and we'll see what CoolWall technology can do for your application.